Okay, so this video is going to be a continuation of the previous video where we were sending serial information from the Arduino IDE to the Arduino Uno, and we were getting it to turn on the onboard LED. And so in this video, what we're going to be doing is sending down more complex data, and we're going to be parsing that data. And so what that means is that we're going to be sending down a message with multiple variables embedded within a single message. And what we're going to be doing is getting it to turn on and off these LEDs that we have here. For this setup, what I have is 3 LEDs, and each of the LEDs has an inline resistor, and I'll put up the circuit diagram in the section down below. We have pin 3, pin 8 and pin 12 controlling these 3 LEDs. You can use any pin that you want for this, it doesn't really matter, just as long as you're not using pins 0 and 1, because they're used for the serial communications. So yeah, I'll just give you a quick demonstration of what we'll end up doing. So here I'm just sending down a message, and we're setting pin 3 to be high, and now I'm going to set pin 8 high, and then I'm going to set pin 12 high, and now I'm just going to set them all low again. And yeah, there we go, easy as that. And so we'll just move over now to the Arduino IDE so I can show you what we're doing. And so this is the commands that we were sending down. So the first one here is just setting pin 3 to be high, so 1 is equal to high here, and then setting pin 8 to 1, setting pin 12 to 1, and then to turn them off I'm setting pin 3 to 0, where 0 is equal to false and false is off. And then we're setting pin 8 to 0 and setting pin 12 to 0. So now I'm just going to show you as well what we can do with the get command. So if we do, say, set pin 12 to 1, pin 12 here is high, we're going to now write this message where it's get 12, and it's now giving us back what the current value of pin 12 is. And so if we set pin 12 now to 0 and we run that command again, we're getting 0 here also. Okay, great. So now what I'm going to do is just go back and start from the code that we ran in the previous video, and I'm going to walk through how we get to be able to doing something like this. So this is the code that we ended up with at the end of the last video on serial communications, and we're just going to be making a few alterations to it. So if you haven't seen that video, you might want to go watch that one first, and I'll put a link somewhere here in the description. The first thing that we're going to do is create a character array called toParse. This will hold the C string that we want to parse the information from. We'll then create another character array called action. This is where we'll store the get set command. It will have a length of 4 so that it can store the characters get or set, and including the null character. Then we're going to create an unsigned 8-bit number to store the pin number that we want to get or set, followed by a boolean pin state that will return the current state of the chosen pin. Moving on to the setup. This time we're not going to use the onboard LED, but instead we're going to control pins 12, 8 and 3. So I'm just going to set the pin mode for each of them to be outputs. Okay, in the main loop, our method for reading and building our C string remains exactly the same. The changes we'll be making will be done in the data ready section. And just a quick recap from the previous video, the data ready section will carry out whatever commands are embedded in the received message. Next, we're going to use the function strcpy, and this is an abbreviation for string copy. And so in this case, we'll be taking the contents of the received characters array and copying it to parse. We make a copy of received characters because it's best practice to leave our initial message intact, as the parsing process can edit the string and information may be lost. In our next line, we'll begin the parsing process by using the function strtok, and this is an abbreviation for string token. This function takes a C string and delimiter as its arguments. A delimiter is a character that is used as a marker to identify where information should be split. And so in this case, we'll be using a comma. We're then going to copy our parse data to our action C string. But before we do that, we need to check that the parse data will fit in the action C string. To do this, we get a size of the action string using the sizeOf function. This function returns the number of bytes in the action string, where each element is 1 byte. We then compare it with the toParseString using the strlen function. strlen is an abbreviation for string length, and this returns the number of characters before the null character. We need to do this to prevent a buffer overrun situation. Next, we're going to get the pin number that we want to control our query. Here we're going to take the C string returned from the strtok and pass it into the atoi function. Atoi is an abbreviation for ASCII to integer, and this converts a C string to a number. Now we're actually going to start doing something with the parse data. Firstly, we're going to set the value of our selected pin. To do this, we're going to use strcmp to compare our action C string with the string constant set. If the two parameters are equal, the function returns 0. To then get the state that we want to set the pin to, we again use atoi and strtok. Now we can write the value of the pin state to the pin number. To verify that the command was successfully completed, we're going to print to the serial monitor the action, pin number, and the current state of that pin. To do this, we'll use sprintf. This function allows us to build a string using formatting. With this, we can create a C string by passing values to the formatted characters. In this case, we're using %s, which means we're passing a string into this location, and %d, which means we're passing a decimal integer. The resulting C string will be copied into toParse, which will then print with serial print ln. We're now going to move on to our next action, get. Again, we'll use the strcmp to compare our action string with the string constant get. And again, if the function returns 0, there's no difference between the two. This case will require no further parsing, as all we'll be doing here is returning the state of the pin number that was passed down in the received message. As before, we'll be using the sprintf function to build the C string that we're going to print and copy it into toParse. Just a side note here, sprintf is excellent for building C strings from other strings, integers, and booleans. But if you need to convert a float or double to a C string, you should use the double to string function dtostrf, which I'll cover in another video. We'll then print toParse to the serial monitor. Finally, if the action string is not recognized, we'll print unrecognized command and the received characters. This here is a good example of why you shouldn't alter your initial message, because we can use it for debugging purposes here. Okay, so that should be the end of the code, and I'm just going to have a quick look over to make sure I haven't made any obvious mistakes before we carry on. Okay, we actually need to set our action C string, the 0 element of it, to the null character. And what this does is it clears the action C string in between data ready events. So just in case there's any errors or anything like that, we want to have our action C string cleared before we start putting new data into it. Yeah, so I think we can upload from here and see, do we get any compilation errors or anything like that. No, everything looks good. Okay, so I'm just going to go to the serial monitor now, and we're just going to test out the code. So what I'm going to do is I'll do a get, and I'll just get the current pin state of pin 3, which is 0 at the moment, and I'll now set pin 3 to equal true or high or 1, whatever, and now I'll get pin 3 again, and yeah, so now we get a 1 back. And we can also test out our simple error handler here and sort of put in some incorrect spelling here. So fet 3, unknown command, fet 3, perfect. And if I just, you know, type in some garbage message here, yeah, perfect. Yeah, so that's it. If you like the video, like, share, subscribe. If you've got any comments, any questions, you can put them down in the comments. I'll do my best to answer them. And so yeah, hope you enjoyed the video.